Okay, today we're doing 5.7, the binomial theorem, and your learning goal is for you to be able to use Pascal's triangle to expand a binomial. So first we're going to talk about Pascal's triangle, which is named after a French mathematician who came up with this triangle to help us expand binomials so that you don't have to write them out. It's just an easier way to help you expand them. So the way the triangle works, this is the pattern, and you have to be familiar with it. So if you notice, the top of the triangle starts off with 1, then it goes 1, 1, and then it goes 1, 2, 1, and the 2 comes from adding 1 plus 1. Okay, then it goes 1, 3, 3, 1, and here again, the 3 comes from adding 1 and 2, and then it goes 1, 4, 6, 4, 1, and the 4 and the 6 come from adding. And even on this side. And you just keep going. 1, 5, 10, 5, excuse me. 10, 5, 1. And then 1, 6, 15, 20, 15, 6, 1. And then 1, 7, 21, 35, 35, 21, 7, 1. We always put the ones on the end. We'll go one more. 1, 8, 28, 28, 56, 70, 56, 28, 8, and 1. Okay, so these numbers represent the coefficients when you're actually expanding your binomial. So, for example, the first one is row 0. The next one is row 1. This is row 2, row 3, row 4, row 5, 6, 7, 8. So I've done like 8 rows. The rows represents the power on the binomial. So if you had to raise something to the 0 power, then the answer would just be 1. If you had to raise something to the first power, or to the second power, those would be the coefficients you would use to expand it. And so forth and so on. So let's actually try one so you can see how it looks. Here's our first example. They want us to do x plus 2 to the 4th power. So instead of writing this 4 times and foiling, we're going to use Pascal's triangle. So what you're going to do is get the 4th row from the triangle. The 4th row looks like this. Okay, so those are our coefficients. So you're going to take x plus 2 to the 4th power, and we're going to expand it. So the way that you do it, and the binomial theorem uses a binomial sum. So this is already a sum, so you're okay. Alright, so the first thing you do, you're going to take your coefficients. I'm going to put them in pink. So for my first term, which is x, I'm going to raise that to the 4th power. And the 2 will be raised to the 0 power, plus, then you'll take your next coefficient, which is 4. Now my x now is going to be to the 3rd power, and the 2 would be to the 1st power. So my first term, the powers are decreasing. The second term, the powers would be increasing. But no matter what, your power should add up to 4 for each term. Okay, and then you bring the next coefficient, which is 6. This will be to the 2nd power, and the 2 would be to the 2nd power. And then the next coefficient is a 4. And the x will be to the 1st power, and the 2 to the 3rd power. And then the last one, which is a 1. The x will be to the 0 power, and the 2 would be to the 4th power. And once you have all of that, you just simplify it. Alright, so you gotta do exponents first. 2 to the 1st power is 1 times 1, so that'll be x to the 4th, plus 2 to the 1st power is 2 times 4 is 8, so that's 8x cubed. And then 2 to the 2nd power is 4. 4 times 6 is 24. X squared. And then 2 cubed is 8. 8 times 4 is 32. X. And then 2 to the 4th is 16. 16 times 1 is 16. And x to the 0 is 1. And there's your expanded binomial. And the more you do these, the faster you'll get with expanding. And that's it. Okay, let's try this one. This is to the 6th power, so we need the 6th row, which is 1, 6, 15, 20, 15, 6, 1. And the easiest thing to do to learn this triangle is keep expanding it until you get to the row that you need. I'm just pulling from the 6th row because I already know what it is, but you want to keep writing the triangle over and over again until you can learn it, or even the row above it. Okay, so those are my coefficients. I'm going to start with 1. Well, first, let me rewrite this. Plus negative 2y squared to the 6. Alright. So, my first coefficient is 1. And my first term is 4x cubed. I'm going to raise that to the 6. And my second term, I'm going to raise it to the 0 power. Plus, pick up my next coefficient. This is to the 5th power now. And my second term is to the 1st power. Plus, to the 4th power, and my other term is to the 2nd power, plus my first term is to the 3rd power, and my next term is to the 3rd power, plus My first term is to the second power, and my second term is to the fourth power, plus this term is to the first power, and my second term is to the fifth power, and then plus my last one. This is to the 0 power, and this is to the 6. Alright, so now we're going to simplify it. Phew. Okay, you're going to do exponents first. So we have 4 to the 6th power. That means 4 times 4, 4 times itself 6 times, which will give us 4,096, and that'll be x to the 18th power. Okay? Plus, well actually, we have negative 2 to the first power times 4 to the 5th power times 6, which will give us negative 12,288. And so I'll have x to the 15th and y to the 2nd. Okay, my next one, I have negative 2 squared, which is 4, so that comes out positive, times 4 to the 4th times 15. So that'll be 15,360, x to the 12th, y to the 4th. Then my next term, which is negative 2 cubed, which is negative 8, times 4 cubed times 20. Now that gives me a minus 10,240, x to the 9th, y to the 6th. Okay? Then, my next term, let me check these off so you'll know where I am. So now I'm here. Negative 2 to the 4th power, which will make it positive, times 4 squared, which is 16, times 15. That'll give me plus 3,840, x to the 6th, y to the 8th. Okay? Then my next term is negative 2 to the 5th. That'll make it negative. That's negative 32 times 4 times 6. So that gives us 768, x to the 3rd, y to the 10th. Let me rewrite this so that I'll know. And then my last term, negative 2 to the 6th power, will become positive 64 times 4. Oh, well, 4 to the 0, so that's 1. So we just have plus 64 y to the 12th. And we made it. And that's Pascal's triangle.